Alright, so in this video we are going to get depth buffering working, but the system's going to get a little complicated or a little interlocked. So I just want to have a look at the interactions that we're going to have with each of our frames in our frame buffer, our swap chain I mean. So here's our swap chain. We have typically 3 frames. This is a representation of a frame, and it will have a bunch of resources. It will have a command buffer, some synchronization objects, some descriptor resources, that's describing the uniform buffer object, so the data of the camera, as well as all the model matrices for all the objects in our scene. And then we're also going to have some frame buffer resources. Those are the color buffer, that is the swap chain image, and the depth buffer. For the depth buffer, we're going to make a simple image and just store it in the frame. So anyway, let's have a look at the lifetime of the program. So we start, we make the instance, we make the device, and by the way, this is a simplified representation. There are other details which we'll get to those. Then we make the swap chain, and at the point that we make the swap chain, each of these frames is allocated and they're given an image, sort of like a color buffer, well, exactly like a color buffer, and then we send a message to each of the frames to create their depth buffer, their depth resources. Then we go ahead and we make the descriptor set layouts. Now, the descriptor set layouts are not strictly needed by the command, by the frame, I mean. They're needed by the pipeline, and when we bind a descriptor set, we need to know which pipeline layout we're binding to. But anyway, then we come to the stage of making the pipeline, and from the frames, we don't need this from every frame, just one frame would be enough. We need some description of the color buffer and depth buffer. I believe it's just the format. We just need the format that was selected. And then we make the frame buffers, and at the point of making the frame buffers, we create a frame buffer for each of the images on the swap chain, frames on the swap chain. Then we go and finalize the setup, at which point command buffers and synchronization objects are created and sent to each frame. And we make the frame resources, at which point we create the descriptor resources and write them to a descriptor set. Then we come time to the render loop. So what we do is we acquire an image, and in doing that, we use a command buffer and some synchronization objects. We grab those from the current frame that we're going to render, and those are used later on and throughout the loop. When we come to drawing the record commands, we bind the resources from the frame buffer, from the frame, and then we submit that, and so on and so on. This loop keeps on going. And then when we clean up, we send a message to each of the frames to say, hey, destroy your resources. So this has been just a brief overview of all of the interactions that we're going to have with our frame objects. I wanted to go through this because, as you can see, they are quite interlocked. And it's also good to understand that the depth resources must be created before we make the pipeline, because they are used in setting up the render paths to know what the attachments are for the pipeline, and so on. But anyway, let's get into it. Okay, so let's go to our scene, model scene, and over here we are creating all of these positions for these objects. I'm just going to loop along in the Z as well, so we'll create them at different heights. So we'll go okay. So I'm creating the triangles at a bunch of different heights, and I'll go ahead and do the same thing for all of the other objects. Now we should probably be generalizing this a little bit, but I'll leave that for a future refactor. It's not super important at the moment. Okay, so there we go. We're creating these at a bunch of different heights as well. So let's run the program, see what that looks like. See, here's the thing. It's not so good. So up here it might sort of look okay, but then as we get down, we can see that these lower stars are actually on top of the stars, which the order's wrong. The order's wrong. And yeah, it's not good. So I guess the question is, and we can make it look worse if we swap the X positions, for instance. So these triangles, the latest things that we drew, will now be at the back, and yet they are appearing on the front. And this is really bad. This is really trippy. So yeah, I mean, how do we solve this? Well, as you can probably guess, the issue is that the objects are not being depth buffered. They're just being drawn in order of their draw calls. So let's create some depth resources and fix the issue. So like I was mentioning, I want those depth resources to be stored in the frame object. So I'll just go to Vulkan util frame and just down the bottom, I guess down here. Okay, so we're going to need an image. Yeah, so an image, a bit of memory, and an image view are the bare minimum that we would need, but I'm going to go ahead and specify a few other things. I'm also going to store a format. Oh, no, not import. I said a format. And I'm going to store the the width and height. And as well as that, I'm going to store some devices. Because I want to be able to set these and then pass simple messages to the frame, tell the frame to do things. So for instance, down here, when I make descriptor resources, I want to simplify this. I don't want to have to tell them which devices to use. I'm going to tell them earlier what they're using. They'll remember that, and then the frames will do their own thing. And similarly, down here, write descriptor set. We should not need this. Now, as well as this, well, this struct is getting a little too big. So let's grab all of this and make it into a class. I'll do that by simply grabbing everything, making a new file, and then just trimming everything down. So I'll just go to the frame header and I will declare, well, this part's fine. I'll declare that this is a class, and I'll worry about the specifics later. For now, I'll just make everything public. This is a little messy, but that's okay. Okay, so where was I? Just checking through, checking that all of this is good. Yep. Yep, this all looks good. Command buffer, yep, excellent. Yeah, okay, I'm happy with that. All right, so in addition to these, make descriptor resources and all of that, I'm going to make another function called make depth resources, and another function, yeah, telling the frame to destroy everything it's got. Oh, okay, so now I'll just pop over to the source file clean this up. There we go. Okay, so same stuff. That's fine. We've just got an error down here because this, I'm going to rename it to logical device. That's using the logical device which has been saved in the instance. All right, so we have that. I guess I'll do the destroy function next because that's, no, actually, change my mind. We'll do the depth resources. Okay, so one thing I need is I need to get the depth format. I'll just write this first. So we'll go, alrighty, make the depth resources. So I want to get the depth format. So I'll pop over to the Vulkan image files and I'll just declare a function down here. Okay, so the way this is going to work is we'll have a whole list of formats so we could possibly use, and then we'll search through them and see which one matches the given tiling and features. And yeah, okay, so let's grab this and go ahead and create it. Okay, so I'll go through each of the candidates. And what I'm going to do is I'm going to get the properties of each of these formats. Maybe I'll just, there we go. Okay. All right, so pass I didn't say, hey, what are the properties? So this is the way the format properties struct works. We have each of these features, linear tiling, optimal tiling, and buffer. Well, we don't need buffer. Now, our tiling, as we've said in the past, is either linear or optimal. So fair enough, let's check that. So we'll say, alrighty, if tiling is linear, and then what I want to do is, if you look at this, these are format feature flags, which means they're bit masks, they're enums, and what we're checking this against is some format feature flags, so these should also be bit masks or enums. A supported, or a minimum supported feature set would have exactly the same bits set. In other words, I would be able to take properties, tiling features, bitwise and them with the features, and the only remaining bits, it would be exactly the same as the original features. Could have extra bits set, but when we bitwise and, it would then come out to exactly the same. So if that's the case, then it's suitable and return it. Otherwise, well, we could have optimal. Okay, fair enough. Well, then we would want to check the optimal tiling features and see if they match. And that's it. Otherwise, if we get to the end and nothing's happened, well, then we're in error territory. Okay, cool. So now we can go ahead and use that. Okay, so for the possible formats, I really just want either all 32 bits to be depth buffer, or it's also possible we could have 24 bits being the floating point depth buffer, and that last byte being the stencil buffer, but I'm not going to use a stencil buffer, so it doesn't matter. Right, so now I'll go ahead and create the image, get its memory, and get its view. Okay, so just as we're going through here, I realized that there's no way for me to specify a format. That's a problem because I'm using this to also create the texture. Yeah, the texture images in the texture class, and they have a different format. So what I'm going to do is I'm just going to put this in here for now. There we go, depth format, and I'll just go over to the image header, and up the top I'll just specify this as well. Okay, good. So then I'll go down the bottom. Oops, wrong file. Okay. Oh, there we are. Okay, and here where we've got the format hard-coded, let's take that and copy it, use it later. But for now, we'll go input format. Okay, and then we'll just go up the top where we're constructing the texture, and then we'll go set that format. Okay, excellent. Close that down, and then okay, so this is going to have to change as well. The image view. Well, let's set that now. Okay, so I'm also going to have to create different aspect masks. Because right now I'm hard coding this to make a color image, but I'll be making a depth view in a second, so we'll change that anyway. So yeah, we've just set the make image view. Just go back to the header. Got that set up as well. Okay, cool. So then we do get an error, so we'll go back to the texture constructor where we, oh, no, down in the make view. And then for the aspect, we'll go Vulkan image aspect flag bits color. And I'll also grab that because I'm going to have an issue in the swap chain. There's actually a lot of these little bits today. It's a lot of little refactoring bits. Conceptually, it's not that hard. The hard part is just that it's all spread out to the four winds. So, where was I? There we go. Okay, so when we create the image view, we'll also say, all right, and that's going to be a view of a color buffer. Okay, think that's fine. Okay, so now we can go ahead and create these. So we'll have the depth buffer. And the depth buffer memory. And then we'll have the depth buffer image view. Did I call that something else? There we go, depth buffer view. Okay, cool. So now I'll go ahead and write the destructor function. Okay, so that has destroyed everything here, but of course we have a whole bunch of other bits that we've created. So let's go back to the main engine and just simplify the way we're working with these frames. So let me go back to the engine and I'll go to make swap chain. That's right up the top. Okay, so at this point, I'll look through all my frames. And I'll set each of them up. So I'll say, hey, set the logical device. And all of that. And then I'll tell the frame to make its depth resources. And that's just creating images, so it's fine with that. Then I'll go down to the frame resources. So down here, pipeline, we'll get back to that. Just double checking this. Yep, so we're setting the everything pretty much, and now we don't need these arguments here. And yeah, that's it. We're allocating the descriptor set. And yeah, just checking my own code. All right, so I guess we do have an error down in prepare frame because, well, it's saying, hey, you told me to write the descriptor set. What device? And they're using the old version. So we don't need that anymore. That's been specified. Prepare scene is fine. Record draw commands, we'll get back to that. Now it's right down the bottom here. Render, okay. It's down here in cleanup swap chains. So see all this stuff that we're doing, well, let's ship that over to the destroy function, which by the way, this should really be a reference. We'll say frame destroy. Okay, so then we go into the frames destruction function and put all these extra bits. And I'll just do a bit of copy paste. Let's double check, no errors, okay. And now we have it. So at this point, we have shipped the frames off into their own class, and we can pass messages to them, tell them to do things, and hopefully this should clean things up a little bit. All right, so we've finally set that all up. The next steps will involve basically telling the program about the depth buffer, telling it to use depth buffering and which depth buffer to use, if that makes sense. So what I'll do is I'll just close down the image stuff, and I think we can close down the frame stuff, and I'll just go over to the pipeline. Okay, so we're at the pipeline here, and there's quite a bit to do here, so I'm just going to try to flow from top to bottom. First thing I'll do is I've got an image format. I'm also going to take in a depth format. Then I'll keep going down. And then it's down the bottom. Okay, down here. So make render pass. I'm going to take in also the depth format. Okay, and then if we look down here, we've got this make color attachment and make depth attachment. Going to copy both of those. Sorry, attachment reference. And I'll just get rid of the documentation for now. I'll fill that in later, I guess. Not now. And I'll just rename this to make depth attachment. And of course, that will be taking in the depth format. And then this will be make depth attachment reference. Okay. And then when we make the subpass needs to refer to both the color and depth attachments. And so I'm going to change this to a vector. And yeah, down here, again, we'll make it a vector. Okay, so again, just a lot of refactoring. Right, so I'll go down to the bottom. Okay, so here I have make render pass. And I'm just going to go ahead and declare two vectors. I'll have a vector of attachments and a vector of attachment references. Okay, so I'll go ahead and create the color stuff. Just double checking here. So I want to push this onto the attachments. And then I'll create the attachment reference and push that onto the attachment references. Okay, then I'll go ahead and do the same thing with the depth buffer. Okay, great. So when I go to make the subpass, I need to put in both of the attachment references. So I'll put that in there. And then when I go to make the render pass, I'll need to put in both of the attachment descriptions. All right, so let's take it one step further. Let's go down to make color attachment. And yeah, so this is fine. I'm happy with this. We'll go ahead and close that down. And this one is also fine. Now, oh, boy, what am I thinking? I'll have to make a copy. So a lot of this doesn't have to change. Just right down at the bottom, I'm going to use this as depth stencil attachment optimal. There we go. And that's fine. And then down here, this will be attachment number 1. And it'll be the same thing. It'll be oh, E instead of D. Okay, fine. Okay, cool. So now I'll go on to the subpass. So again, this will be a whole set of attachment references. So I'll say, okay, we'll have one color attachment, and that will be attachment 0. We know will be the color. And then the depth stencil attachment will be the same. It'll be attachments number 1. We don't specify the number of depth stencil attachments. Why would we? There's always one. Okay. 1 or 0, right? So there we have it. Create our subpass. Then we create our render info. And just like before, this should be a vector. So now to get the, it's just straightforward stuff. To get the attachment count, we'll get the number of things in the attachments vector. To get the pointer to them, we'll get the data. And yeah, one subpass, and there it is. Okay, so that is all well and good. So now the depth buffer is specified as one of the components of the render pass, but we also need to specify with the pipeline how that depth stencil test is going to be performed. It's a little distracting, just got to minimize these. Or do I even have to? Okay, so it's up to us where we put this. I mean, I'm trying to more or less mirror the way this shader works, so often it's treated as if the depth test happens after the fragment shader. In practice, it can be the other way around, but there we have it. So I'll specify the depth stencil stage. So there we have it. Yeah, we are... Oh, wait a second. That should be depth test, shouldn't it? Not depth bounds. Yeah, okay, so we're doing or enabling depth test. We should be writing to the depth buffer. Okay, the comparison operation is less. So remember, a depth of 0 in Vulkan is at our eye level. A depth of 1 is at our far plane. And so we want this to be less. Yeah, and we're not going to have bounds test or stencil test, and we just register that as the depth state. Now, down below, we are getting a complaint. Where is it? It should be the render pass. Okay, so we need to also pass in the depth format. Okay, so now that should be fine. In theory, we'll just need to go back to the engine at the point where we create the pipeline, and I'll just set this so we'll say we can just take the first swap chain. Oh, no. Frames. Why are you saying format? Take the first swap chain frame and get its... No. Bad Visual Studio. IntelliSense. More like unintellisense. Okay, so yeah, just any of the frames are always guaranteed to have at least one frame, I guess. So just grab the depth format. They're all the same. Okay, so that's all well and good. But of course, just because the pipeline expects it doesn't mean that it's... I mean, how will we know which depth buffer to use? Well, that's registered with the frame buffers. So just pop in here. Okay, and this is fine. So we're passing along the swap chain frames to the make frame buffers function. And then if we go into the frame buffer, make frame buffers right down the bottom here, where we go to attachments, we have the image view and then the depth buffer view. So there we have it. That is all set up. And now with the render pass knows which views to reference when it says, hey, I want to write to the color buffer. I want to write to the depth buffer. It's got those. Okay, cool. We are so close to done. What I'll do now is I'll just go to the engine, into the record draw commands. And right down here, so we have this clear color. I'm just going to reset this or change it up a little bit. All right, so what I'm doing here is I'm specifying the color with which I want to refresh the color buffer. Okay, no worries. And I'm also specifying a depth stencil value with which to refresh the depth. Now, I am providing a stencil because in the off chance that our format is depth 24 stencil 8, we will probably need to set a stencil value as well. But the really important one here is the depth, because the depth of 1 is at our far plane, so anything closer than that will draw. So now all I need to do is specify those. And just pass them along, so we'll go okay, so let's see how we did. See what I missed? Give it a go. Okay. Looks like it's working. Yeah, we've got no errors. Okay, no, that's really good. I'm happy with that. Okay, so now we can see that if we look down the bottom, the stars are not overwriting each other. Now, let me reverse the order. So we'll be drawing the triangles first. Just go back to the scene and reverse that order. So now the draw order is opposite to the distance order. And we're getting the same thing. So see, we're seeing the triangles, nice row of triangles, and even though these stars are being drawn later, they're not over. You know what I mean? It's working properly. I'm happy with that. And yeah, so there we have it. Very cool, very cool. So we probably have all the mechanisms in place to the point where we can start looking at loading OBJ models, and I'll have a look at that in the next session. All right, so have a good one, and I'll see you next time. Bye.